It's not much. Different types of equations. The molecular equation is what we've been looking at. We show each of these compounds as molecules, even though we know that they're not molecules, they're ions. But we show the formula units, and we show all of them like that. But actually, all of these aqueous substances are separated into ions in solution. And so a complete ionic equation shows all of the species as they're actually present. So it shows potassium ions, hydroxide ions, magnesium ions, nitrate ions, reacting to form potassium ions, nitrate ions. And this is a solid, and so we still write that as a molecule. And then the net ionic equation is kind of like your net paycheck, right? It's what you get to take home. It's only the species that actually change. Because some of them are just, they came and they mingled and nothing happened to them. The potassium didn't really change, and so we'll see that in a minute. So the guidelines here, anything that's an aqueous ionic compound, you're going to write the individual ions. The aqueous strong electrolytes include the soluble salts, that's the ionic compounds, strong acids, and strong bases. If you have a solid, a liquid, or a gas, those are going to be written as molecules. And those guys include insoluble substances, weak electrolytes, non-electrolytes, and the weak acids we write in that molecular form. So if we have this reaction here, lead nitrate aqueous reacting with potassium chloride aqueous to form solid lead 2 chloride and potassium nitrate that's aqueous. All of these aqueous ones get written as ions. There's Pb2+, and there were 2 nitrate ions in that, so we have 2 NO3-. Here we have 2 potassium ions and 2 chloride ions. And that's reacting to form, this is a solid, so we write it, we keep it intact, but this one was aqueous, and so we separate it into its ions as well. Now we can see that potassium was an ion before the reaction and is still an ion after the reaction. Nothing happened to it. We call those spectator ions. You know, you go to a boxing match and you watch the 2 guys in the ring beat each other up, and they get bruised and bloody noses and stuff. Does that happen to you as a spectator? Not unless things get really out of control, right? You go, you watch, you come out, you don't have a black eye. Nothing happened to you, you were a spectator. These are the spectators, the ions that are unchanged in the reaction. They did not undergo a chemical reaction. They were in there, they mixed, but nothing happened to them. So we don't include the spectator ions in the net ionic equations. You can think of them as canceling out. We got this guy on the left and this guy on the right. We just cross them off, and we write down what's left. The reaction that occurred was between lead ions and chloride ions to form lead 2 chloride. Yes?
Would it also be considered excess reactants?
Would they be considered excess reactants? That's a good question. One of them would be, it's highly unlikely that you'd have exactly twice as many chloride ions as you have lead ions in this solution. So one of these original compounds would be in excess and one would be limiting. And so the ion associated with the excess would be excess, and the other would be, I suppose you might think of it as, well, it's just hanging around. Yeah. So writing these equations, and this is what we just have to get to so you can do that pre-lab for Wednesday. Write the complete ionic and net ionic equations for this reaction. HI, what kind of a compound is that? It's an acid. Is it a strong acid or a weak acid? Is it? I can't remember.
Strong acid.
Okay. I'm realizing I forgot to tell you which are the strong acids. There's a short list of strong acid. There's nitric acid and sulfuric acid, and perchloric acid, and hydrochloric acid, and there's one more. Is it hydroiodic acid? I don't think so. Hydroiodic and hydrobromic? Okay. I'm just having a complete brain fart on that. Hydrofluoric is not a strong acid. I do remember that. So you have to ask yourself, what kind of an acid is it? If it's a weak acid, then you don't separate it into ions. There's a short list of strong acids, and you look on the list. If it's on the list, it's a strong acid. If it's not, then it's weak. So I'm going to separate that. 2HI is going to give me 2 H plus ions and 2 I minus ions. And then barium hydroxide, that's an ionic compound, is aqueous. So we'll separate that into ions as well. So barium and 2 hydroxide ions. And then in the products, we've got H2O is a liquid. Solids, liquids, and gases are not separated into ions. So I've got 2 H2O liquid. And then I've got another ionic compound, Ba2 plus aqueous, and 2 I minus aqueous. That's the complete ionic equation. Shows all the ions. Which of those ions are spectators, not being changed? Look for things that are the same on the left and right of the arrow. Here we've got barium 2 plus, barium 2 plus. I'm going to cross those guys off. They came and they watched, but nothing happened to them. What's the other one? 2 iodide. So the net ionic equation then is we just copy down what's left. 2H plus aqueous plus 2OH minus aqueous gives us 2H2O liquid. Now what's funny about that balanced chemical equation? It's got all these 2's in it. It's balanced, but the coefficients aren't the lowest. And so we'd want to cross those 2's off, ideally. Any questions? Yes?
What if it was like 2 and 4 and 2? Would you reduce that to?
Yeah, if it was 2, 4, and 2, you would reduce it. Oh, thank goodness, we can stop there.